Hello everyone, my name is Vishwaa Shah. I'm a graduate student and research assistant at the University of North Florida in the Biomedical Informatics Lab. Today I will present our work on using the US Dietary Guidelines as computable biomedical knowledge to help interpret nutrition misinformation on social media. Nutrition misinformation is increasingly common on social media where users often seek health and dietary advice, and prior misinformation research has largely focused on platforms like Twitter or X and Facebook, while Instagram, with over 2 billion monthly users, has received comparatively less attention. Instagram's influencer driven ecosystem often amplifies nutrition content shaped by trends and simplified health narratives rather than evidence based guidance. In this work, we focus specifically on misinformation narratives surrounding seed oils and omega 6 fatty acids, which are frequently portrayed online as toxic, inflammatory, or harmful. On the right here are a few examples of the types of posts we analyzed. These narratives often conflict with recommendations described in the US dietary guidelines, making them a useful domain for studying how computable biomedical knowledge can support misinformation interpretation. To address this problem, we propose a retrieval augmented generation framework that operationalizes the US dietary guidelines as computable biomedical knowledge. We collected a data set of 317 Instagram captions. We focus specifically on captions only for reproducibility and privacy. Each post is independently annotated by three expert nutritionists using the US dietary guidelines as a reference standard. Labels are binary, so either consistent or inconsistent with the guidelines, with strong inter-rater agreement, which was about zero point 0.8, and hence we used majority voting to construct the final gold standard labels. On the system side, we convert the dietary guidelines into a sentence indexed knowledge base to enable retrieval of relevant passages for each post. And instead of prompting the model in isolation, we provide both the Instagram caption and retrieve guideline excerpts in a structured prompt designed for evidence-based evaluation. The model then outputs a classification along with supporting evidence and a natural language explanation. We evaluate the system against expert labels to assess how retrieval grounded reasoning improves interpretation of nutrition claims. To make this more concrete, here is an example of the system in action. We analyze an Instagram post claiming that seed oils are inflammatory and should be avoided in favor of nourishing fats, common framing in online nutrition content. Our system retrieves relevant guideline expert stating that vegetable oils are part of healthy dietary patterns and recommending unsaturated fats over saturated fats like butter and lard. Given both the post and retrieved context, the model classifies the claim and explains that the inflammatory seed oils narrative is not supported by the dietary guidelines. Across all Instagram captions, we evaluate classification performance using the F1 score. We observe an F1 of 0.88 for seed oil related content and 0.71 for omega 6 related content. Performance is higher for more explicit claims, such as those involving seed oils, which align more directly with guideline language. In contrast, omega 6 content tends to be more nuanced and requires more indirect reasoning from the dietary guidelines. This highlights an important limitation, which is retrieval grounded performance depends on how explicitly and comprehensively concepts are represented in the underlying knowledge base. This work has three main implications for computable biomedical knowledge. First, it shows that public health guidelines can be structured as computable, retrievable knowledge rather than static document, enabling direct use in language model reasoning. Second, retrieval grounded language models improve interpretability by grounding outputs in explicit guideline evidence instead of unsupported predictions. And finally, this approach is extensible to other domains beyond nutrition, wherever structured clinical or public health guidelines exist. This study has several limitations that motivate future work. The dataset is limited to English Instagram captions on seed oils and omega 6 fatty acids, restricting applicability across topics, platforms, and cultures. We analyze only text, excluding images, videos, and engagement signals. Our evaluation uses only binary expert labels, which may oversimplify nuanced claims, and we evaluate only one retrieval augmented model without comparing alternatives. We also focus mainly on classification performance rather than faithfulness, retrieval quality, or explanation quality. Future work will extend this to multimodal data, broader domains, and more robust evaluation of retrieval grounded systems. Thank you for your time.